So let's talk about significant figures. In class, you guys are going to do an activity where you practice taking some measurements, and you're supposed to be recording the right number of digits. And so we're just going to review what it is exactly you're doing in order to get the right number of digits, and then how to correctly count if I, let's say, didn't do the measurement myself, but just have a number that's given to me. I want to see how many significant figures there are, especially if I'm going to use that number to do calculations. So this is a sample of a scaled measurement device. So we have markings at every 1,000, and so this little blue section up here, that's representing our thing that we're measuring. So notice that I know my measurement is somewhere between 3,000 and 4,000. So I'm going to write down as my measurement 3,000, and then basically because my markings, so my graduations, my markings, whatever you want to call them, those are in the thousands place. That means that when I go to write down the number in the hundreds place, I'm really estimating. I don't know exactly. It looks like maybe about 3,800 to me. So that's what I'm going to put down, 3,800. Now notice that, again, someone else might come along and say, well, that looks like 3,700 to me, or that looks like 3,900 to me. But the point is that this place is being estimated. So I know this for sure. This is estimated. Once I estimate one digit in my measurement, these other places that remain until I get to the decimal point, I cannot estimate them any further. So if I just made up numbers here, if I said I think it's 3,811, once I've already estimated once, you really can't take the liberty to estimate additionally. So I'm going to put these zeros here. These are called placeholder zeros, because if I didn't have those there, the number would look like 38, and that's not what I mean. I mean it's 3,000 something, and so these zeros count as placeholders. So that being said, when I go to look at those significant figure rules, which seem very confusing and have a whole lot to them, when I go to look at those rules, it is counting these two non-zero digits, and we're not counting these two zeros because they're considered placeholders. And so the idea is that if there's no decimal point at the end of the number here, these zeros at the end of the number are not counted. They're considered to be placeholder zeros. So this number would have two significant figures. I'm going to label that, abbreviated SF, as my significant figures. Can't really see that well, but this says 2SF. Over here, we've got another set of lines, and again, different measurement instrument. Can't see what you are. No, you can. Can't see it. Anyway, so notice this first line over here. We've got this marking is definitely between 100 and 200. And I'm supposed to be reading the bottom of the meniscus. That's what this curved line is representing. So we're going to read right about here. So I'm going to say that's about halfway between the 100 and 200. So I'm going to write my number down as 150. Again, I know for certain the 100. This next digit, though, that's where I did my estimating. So in the tens place, that's estimated. And so, again, the 0 is just put here as a placeholder. And again, that would be counted towards my total number of significant figures. So this would be two significant figures. The non-zero digits at the beginning of the number, this trailing 0, if there's no decimal point, that tells me that this is just a placeholder 0 and is not counted as my significant figures. Up here, so if you want to take a look at this, and this to me looks like, well, looks like about 390, so I'm going to say that that's 390. Again, it's definitely 300 something, and then I'm going to say that it's a 9 there. And I'm estimating the 9, so then this has to be a 0 just as a placeholder, because I'm already kind of unsure about the 9, but I'm estimating it at 390, and so there's my number. So this also has just two significant figures. This would be the placeholder. Similarly, when we're looking at other numbers, so decimal numbers, I have see that number? Okay. So these are leading zeros, and leading means that they're before the first non-zero number. Okay, so these leading zeros, whether they're, notice this is before the decimal point, this one's after, any zeros before you get to the first non-zero, those are called leading zeros, and those are not counted towards our significant figure total. Okay, so do not count these towards my significant figures. all non-zero digits always count, and any zeros that come up between them always count. So when I hit my first non-zero digit, so non-zero means anything that's not a zero, I'm going to start counting here. So this would be 1, 2, 3, and then the other debate is, well, the zero at the end. When we had zeros at the end of this number, we weren't counting it. We get to the end of this number, am I supposed to count it? And so the deal with zeros at the end of the number is if there is a decimal point, the zeros at the end of the number do count. Because again, my measurement stops being written down as soon as there's a number that I've estimated. So because the zero is what we've ended with, and again, there is a decimal point, we know that this is considered to be an estimated digit, and therefore that zero needs to remain on there. It is part of the significant digits. So we're not counting the leading zeros. We are counting starting with the first non-zero and going all the way to the end of the number, and that includes any and all zeros at the end of the number. So as soon as you have a decimal point, as soon as you hit the first non-zero, you start counting, and you keep going. So this would have 4 significant figures in this number. Likewise, let's take a look at another number. Let's do 15,230. That is not a real number. That's not 15,000. Let's do 152,000. How about that? So 152,030. So I'm going to start with my first non-zero digit, start counting. So there's 1, 2, 3, 4, 5, and then I get here. If there's no decimal point, I don't count it. So this is just a placeholder because there's no decimal point. So this would be 1, 2, 3, 4, 5. That has 5 significant figures. If I had this number, so notice starting at the left-hand side of the number, first non-zero, start counting. 1, 2, 3, 4. If there's a decimal point, and these zeros at the end are going to be counted. So 1, 2, 3, 4, 5, 6. So this has 6 significant figures. Let's start again. Or take another look at another example. So let's say I've got 5, 1, 0, 3, 0, 0. So again, start with the non-zero. 1, 2, 3, 4, 5, 6. There's a decimal point. All of these zeros are getting counted, even the ones at the end of the number. So 1, 2, 3, 4, 5, 6. So this would have 6 significant figures. So there you go. Those are your rules demonstrated for counting significant figures. And again, we never, ever, ever count leading zeros. So a leading zero can be something before a decimal point, or it can be after the decimal point, but these numbers are before the first non-zero digit. Those never get counted. Any numbers, any zeros at the end of a number that has a decimal point, those get counted. Any numbers that have a 0 at the end and there's no decimal point, they never get counted. So the way you can remember this is no decimal point, no counting the zeros at the end, or decimal point, count the zeros at the end. So yes, decimal point, yes, count. There's my thumbs up, there you go. Yes, decimal point, yes, count. No decimal point, no, don't count those trailing zeros. Yes, decimal point, count them out, count the zeros at the end. No decimal point, don't count the zeros at the end. Got that?